Hello everyone, this is Jiachen. I'm here for the Ece6303 homework 5. This is problem 2. And firstly, I will analyze this question first. So basically, we have this region here. So we know the relationship between x and y. And we know that we need to draw the non-zero part. So this is the condition to have the non-zero part. So basically, this is the graph we have. And then x equals to y is just this part. And x equals to like 1 over y is just like here. And this is y, this is x. So this is basically what we have here. And this region is like beyond this part and beyond this part. So basically the region is just here. After we write down the region, we know that we can we need to separate this function into two parts. It's like this is one, we can to separate the function less or equal than 1 and greater than 1. This is two basic concepts and very intuitive. And then for the question 2, so the density function, we also obey the rule that the integral of this function here, fxy dx dy, will need to equal to 1. So basically we need to compute the integral of this function here. And we know that we need to separate into 1 to the infinity. And so basically we know that y runs from this part, this points is just actually it's like here, it's like this point is just 1 over y, and this is y. So we need to compute each slice of this part, so to get the whole bunch of the joint distribution. And after that, we can to get what is A here. So this is a very general case. We first integrate x, then integrate y, then we can get the final idea. So it's much simpler to let y runs here. So each slice is just basically this kind of line, parallel lines, to get the whole bunch of the joint point. For the third part, we need to write down the marginal destination function. So this is quite simple, I think. So fy, I will change another color. Sorry about that. Fy is basically just fxy, and we need to integral corresponding to x. Then we can get the idea, the same thing. So it's just fx is just integral with dy. And that's it. And after we have this function here, it's quite simple to verify the density function. What we need to do is just take the integral of fy, compare it to 1, and the integral fx, compare it to 1. So that's the whole idea of this question. And that's it. Let's see the solution for this part. So basically, we first draw the picture here, so we know that the lower bound and this is the upper bound. We have the image here, and what we need to do is to, this is a, we need to integrate from like 1 to infinity, from here. So this is x slice, from x is here and y is from here. I will change to segregate. So this is y, it's running through this, and x is just basically running through this. It's from 1 to infinity, 1 over y to y. This is y. So we can separate it to x and y. And this is very simple to get. And then we can let this as a w. So we can write down the new word to represent law in y with w, and then we can simply get the exponential integral. It's very simple to calculate, and then we can get the a. After getting that, we can just integral based on this fxy, fxy, and the integral dx. Then we can get the result of y. After that, we just use the same idea here, integral y, then we can get the result of x. So basically, that's it. And we need to calculate this, as we said, to verify the density. But we know that this one is equal to 1. It's very simple to know that this is like a property of this lowing function. But this one is greater than 1. So basically, this can be a density function, and this cannot. And I think that's it. I think you can learn from it is that we can get the distribution function separately and get it together. Use the same idea to take the integral with corresponding to different variable here, or here is dx dy. Thank you for listening.